welcome to Educate. Today we will continue the chapter Units and Measurements. We have studied up to certain things, but today we are going to start with the principle of homogeneity. Principle of homogeneity means each term in given equation has same dimension. Suppose you are given x equals a plus bt plus ct square plus dt cube, where x is distance. Now we have to find out the dimensions of a, b, c and d. As I told you, according to principle of homogeneity, each term in given equation has same dimension. Here x is distance, so dimension of x is L. So we can say L equal to A, means dimension of A is same as distance, so it is L. Now if we consider this term, so BT must be equal to x, so BT equal to x. So B has dimension x upon t, so x is L and small t has dimension t, so we can say LT minus 1. If we take third term, it is CT square. It should also be equal to x, so we can put the dimensions here. The dimension of C must be equal to x upon t square, so this gives L upon t square, or you can say it is L t power minus 2. If we consider next term dt cube, so that has also same dimension, that is x equal to dt cube. So it is simple, we just put the dimensions of x and t. So d will have dimension x upon t cube, that is L upon t cube, or LT minus 3. I think you have understood. Now let's consider another equation and we apply the principle of homogeneity. So here we are given E equals b minus x square divided by at, where E is energy. Now first of all, here there is negative sign. It means these two terms have same dimensions, that is dimension of B must be equal to dimension of x square. So it is simple. So B has dimension of L square. Here B has dimension of L square, x square is L square. So we can easily find the dimension of A. So here instead of B minus x square, we can write L square, and E is energy. If you remember energy you can take either mgh or half mv square, and you put the dimensions here. So m and velocity lt minus 1 whole square, that is m L square t power minus 2. So we have got the dimension of E, we have got the dimension of B minus x square, that is L square, and we have to get the dimension of A. So it is very simple. A will be equal to L square and divided by here E into T. L square here dimension of B minus x square, both have same dimension, so that is why I have written L square. Here we have to find out the dimension of A, So we put the dimension of this thing, and then E has come over here. So E is energy, we can write it here. So this will come L square divided by E is m L power 2 T power minus 2 times T. We can simplify to get the dimension of A. So here we have applied the principle of homogeneity to get the dimensions of constants. Sometimes there are 2 or 3 constants whose dimensions are to be found, and we can do them easily. We can take another example. We are given pressure equal to A minus T square divided by Bx. Here P is pressure. So if you remember, pressure is force upon area. So we can put the dimensions of force. Force is mL T power minus 2 divided by area is L square. So from here we will get mL minus 1 T power minus 2. So this is dimension of pressure, and here if we apply principle of homogeneity, so dimension of A must be equal to dimension of T square. So we can say A must have dimension of square of time. So we have got the value of A. Now in order to get the dimension of B, we can put this B over here and P over here. So our equation will be B equals A minus T square divided by P times X. Here A minus T square means dimension of A or dimension of T square, so that is just T square. We write here T square, and here dimension of pressure we have got as m L power minus 1 T power minus 2 times X. X is L. We can simplify to get the value of B, and suppose in our question sometimes they ask that find the dimension of A and B or dimension of A upon B. So you can easily put these two dimensions and then you can evaluate. So I am not doing that. That is your part. Now we are going to see some other things. So we have question f equal to a root x plus bt square. We have to find out the dimensions of product A into B. Also we can find the dimension A upon B or A into B. Any one or both we can evaluate. The only thing that we have to do is to get the dimensions of A and B separately. So here, as I told you, that as per principle of homogeneity, each term must have same dimensions. So we can say that in order to get the dimension of A, we can write A equal to f upon root x. Now what is f? F is a force. So force has dimension ml T power minus 2 divided by root x. X is distance whose dimension is L. So we can write it as root L or L power half. Now we can shift it to numerator. So we will get m L power, here power is 1, here power is half. So 1 minus 1 by 2 and T power minus 2. We can further simplify it. So we will get m L power half T power minus 2. So we have got the dimension of A. Similarly, second term, so we can say dimension of F must be equal to dimension of B T square, or dimension of B can be found by dividing F by T square. We put the dimensions. So dimension of force is mLT power minus 2 divided by T square. So we can take this T square to numerator. So this gives mLT power minus 4. Now, whether we have to evaluate A upon B or A into B, since we have got the dimensions of A and B separately, so we can do either division or multiplication to get the desired answer. I think you have understood. Now, let's see some other questions. Here, we are given van der Waals equation, that is P plus A upon V square V minus B equal to RT. Here V is volume, P is pressure, R is gas constant and T is temperature. Our concern is to get the dimensions of A and B, then we can find either A upon B or A into B as per question. So here, if we apply the principle of homogeneity, which says that in addition and subtraction, only the quantities having same dimensions are put. So here, dimension of B must be equal to dimension of V. So B is equal to L cube. It's very obvious, volume minus volume. Here, this term A upon B square must have the dimensions of P. P is pressure, so let's find out the dimension of P first. So this is force upon area. So force is mLT power minus 2 divided by L square. So this will give mL power minus 1 T power minus 2. So this term has dimension mL minus 1 T power minus 2. According to principle of homogeneity, definitely A upon V square must have dimension of P. So we can write here P equal to A upon V square. Our concern is to get A, so we can say A is equal to P into V square. And dimension of pressure we have found, that is mL minus 1 T power minus 2 into volume square. If you remember, volume has dimension L cube, so we write L cube and square of it, and then we can simplify to get the answer. Now let's proceed. We are going to take some other questions. I think you have understood how to apply this principle. Now another concept is rounding off. You know this concept very well, that if we want to remove some digits after decimal, then certain increment can be made or not. That depends. Suppose you have a number 3.42 and you want to remove this 2. So this number will remain unaffected. If you write 3.415 and you want to remove this 5, in that case this number will be increased by 1. So our answer in this case will be 3.42. Whereas in this case this will remain 3.41. If we make it 6, 3.416, so this number will get increased by 1. So we can say that the number to be removed is 5 or more. In that case, previous digit is increased by 1. But one thing you have to note, suppose you have 3.25 and you want to remove this 5. Let's compare by writing two numbers, 3.35 and 3.25. Here we want to remove this 5. So there is one question. If previous number is even, then we don't increase. We just write it 3.2. We cannot write 3.3. But here previous number is odd. When previous number is odd and we want to remove 5, in that case there must be an increment. So 3.4. I think you have understood the concept. If it is suppose 4.6251, here there is no problem. If you want to remove 5, since there is another number here, so this is 51, definitely it will make an increase. But 4.6250 are just 5. Then you have to apply this rule that if previous number is even, in that case there is no increment. But if previous number is odd, in that case you have to increase it by 1. So I think you have understood. Suppose this is 350 and you want to remove this 5, 0 is automatically removed. So this must be increased by 1. So your answer should be 4.64. So this is how a rounding off is done. You can take any number, you can round it off up to certain number of places. Suppose I'm giving you another number. Suppose you are given, say, 45623 and you want to remove these 3 digits. So there is no problem. Put zeros. So 456000. But suppose you want to remove these 2 digits. Then this digit will experience the increment of 1. So this will become 456300. Further, suppose you want to remove this 3. In that case, 6 will remain intact. 45600. Suppose you want to remove this 6, then this will be increased by 1. So this will become 46000. So like this. So this is one concept and you have studied it at lower level also. Now we are going to study another concept, and that concept is significant digits. So here we are going to study significant digits. So as far as significant digits are concerned, suppose we have number 4532 like this. Here all 4 digits are significant. So there are 4 significant digits. But suppose we put some zeros, 14000. So only these 2 digits are significant. These zeros are not significant. But suppose the same thing we write 000 and after that we put some unit. So if we put this unit, in that case all 5 digits are significant. Another concept, suppose we have 10005. Here these zeros are significant, but had it been 0000, so these zeros are insignificant. Here there are 5 significant digits, whereas here there is 1 significant digit. Now consider cases where decimal is present. If there is decimal, in that case, what will happen? So suppose we are given 1.0025. Here all 5 digits are significant. But suppose there is 0 and then 0025. So only 2 digits are significant. But if we write 25.00, so after decimal, all zeros are significant. So here 4 digits are significant. But keep in mind, here these 2 zeros are insignificant since there is no number. But here these zeros are significant. Now there is a question. What is use of knowing the significant digits? Whenever we do addition subtraction, multiplication or division, in that case we take into consideration the significant digits. Now let's see, suppose we take some questions of addition. Suppose we have 2 plus 4.5 plus 6.8, and we have to add it. So if we add, what do we get? We will get 13.5. 13.5. Now we round it up to two significant digits. So this will become 14. Here, since previous number is an odd number, so definitely there will be increment by 1. Take another example. Suppose we have 7.21 plus 12.141 plus 0.0028. We find the addition. It comes out to be 19.3538. Now, least number of significant digits, but in such cases where decimal is present, we have to take the least number of decimal places. Here there are 2 places after decimal, here 3 places, here 4 places. So our answer should be restricted up to 2 places of decimal. So we have to take up to here. These 2 digits must be ignored. So our answer will be 19.35. Now, in case of subtraction also same thing will happen. Suppose we have a number 6.807 minus 4.27153. We subtract it. So if we subtract, so subtraction will give 2.53547. But here there are 3 places of decimal. Here there are 5 places of decimal. So our answer should be restricted up to 3 places of decimal. So our answer will be 2.535. These 2 digits will be ignored. Now let's consider some questions of multiplication. In case of multiplication also, we will take care of significant digits. Like suppose we are given a cube whose side is 7.20203 centimeter. Now we have to find out its surface area. Surface area of the cube, if you remember, it is 6a square. 6 times this value, 7.203 squared. This is little complicated calculation. So after calculating, we will get 311.299254. So here after decimal there are 6 digits. But our answer should be restricted up to least number of significant digits. So inside means when we have considered the edge of the cube, it has 4 significant digits. So our answer should restrict to 4 significant digits, that is 311 point. This 2 will increase by 1 because this digit is 9. This is 3 and the unit is centimeter square. Similarly, if we take, suppose we are given radius of a sphere as 1.41 centimeter, and here if you notice there are 3 significant digits. So your answer should be restricted to 3 significant digits. Now we have to find out this volume. If you remember, volume is given by 4 by 3 pi r cube. So we put the values and evaluate. So after evaluation, what do we get? We will get 11.736. If it is centimeter, so it will become cm cube. Now we have to restrict our answer up to 3 significant digits. So for this, we have to ignore these 2 digits. When we ignore these 2 digits, then our answer comes out to be 11.7 centimeter cube. I think you have understood. Now, in case of division, what will happen? The same thing will happen. We will use the concept of significant digits, and then we will write our answers. So let's see how. We have to find out density when mass is given. M is given as 5.975 into 10 to the power 24 kg. This is mass of Earth. And radius is given, radius of Earth is given as 6.37 into 10 to the power 6 meter. Now density we have to find out. So for finding density, we can write mass upon volume. Here volume of sphere is to be considered, that is 4 by 3 pi r cube. So we write the values. 975 into 10 to the power 24 divided by 4 by 3 pi into r cube. R is this much, sorry, 6.37 into 10 to the power 6 whole cube. We can simplify. Calculation you can easily do. I know that you all are intelligent. So 0.005517 into 10 to the power 6. We can write here, we can count 1, 2, 3, 4, 5, 6. It means this number we will get. So 5517. But we have to give answer in terms of 3 significant figures, because here radius is given in 3 significant digits. So our answer should be restricted up to 3 significant digits. So we can write it as 5510. So here, sorry, I'm mistaken. Since 7 is more than 5, so this will become 2. So we can do the correction. It will become 552. And unit kg, density we are finding kg per meter cube. I think there is no problem. Now we can consider some other aspects. So let's see what are they. So we are going to consider about errors. So different type of errors are there. So whenever we do some experiments, then errors occur. And in order to remove those errors, we apply different type of methods. So we are going to study. So what is formula for error? Error means deviation from true value. So true value minus measured value. True value minus measured value. For example, suppose we measure a quantity whose different values are A1, A2, A3, A4, A5, an. So what is accurate value? So in order to get accurate value, first of all, we find their average. So A bar is equal to A1 plus A2 plus dot 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 plus AN divided by N. So here we can get A bar. Now we have to find out the deviation of each measured values to get the errors. So we can calculate the errors like we say delta A1. So delta A1 means this is A bar, this is measured value. As per formula, true value means average value here. So we can say A bar minus A1. Similarly, delta A2 is A bar minus A2. But keep in mind, for doing calculations, whenever we will make use of these things, we always take modulus value. Even if we evaluate here normally, but generally we have to use modulus value because we have to get the average of these values without negative sign. Sometimes suppose average value is say 2.7 and measured value say A1 is 2.8 and we find error. So here delta A1 will be equal to 2.7 minus 2.8, which is minus 0.01, right? Sorry, minus 0.1, not 0.1, which is minus 0.1. So this is negative value, but while taking it into account, we will take its modulus value, so that will be just 0.1. So now, after calculating these errors, what do we do? Again, we find their average. So we can say delta A average. So delta A average will be equal to modulus of delta A1 plus modulus of delta A2 plus dot 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 plus modulus of delta AN divided by N. Now we have got A bar, we have got delta A bar. So correct value will be A bar plus minus delta A bar. So this is correct value. We will try to understand it by taking a numerical example. So let's see. Now we have certain values. So we are going to calculate here values are, suppose length measured is first time it is 2.48 centimeter, second time it is 2.46 centimeter, then third time 2.49 centimeter, then next time it is 2.5 centimeter, and then next time it is 2.48 centimeter. Now, first of all, the first step is to get A bar. So A bar, you understand that we find the sum of these are and then we divide by number of turns. So there are 1, 2, 3, 4, 5 turns. So we write directly the values. So 2.48 plus 2.46 plus 2.49 plus 2.50 plus 2.48 whole divided by 5. We can evaluate it. So it will be equal to 2.482. 2.482. So we can write the answer in terms of 3 significant digits. So 2.48. Now next step is to find delta A1. So 2.48 minus 2.48. The first value. This is 0. Similarly, we subtract for this to get delta A2. So delta A2 will be equal to 0.02. Then for this we can get delta A3. It will be negative 0.01. Then for this delta A4, so we can subtract this. So we will get 2.48 minus 2.50. So this is minus 0.02. For last one, delta A5, it will be 0. Now, as I told you that delta A values are always taken as absolute values, so negative sign will not be used. Now we find the average of these values. So we say delta A bar will be sum of these values, modulus of delta A1, modulus of delta A2, plus dot 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 plus modulus of delta A5 whole divided by 5. We put the values and then we evaluate. So it is simple, you can put the values, but keep in mind you don't have to write this negative sign. So you will get 0.01. So you have got A bar as 2.48 and delta A bar as 0.01. So if you have to write correct length, so you will write correct length because length was measured like this. So L will be equal to A plus minus delta. A you have got, that is 2.48, and then plus minus 0.01 centimeter. Now suppose you want to convert it into percentage, or you want to find out its percentage error. So what do? We just write this value divide by this value into 100. So percentage error is equal to 0.01 whole divided by 2.48 multiplied by 100, and then you can easily evaluate and it will come out to be 0.4%. Now let's proceed. These questions are simple and you know very well the calculations, although they are little lengthy, but don't worry, you can do. Another question, for measuring time period, different values are given, like T1 is given, T2 is given, T3 is given, T4 is given, T5 is given. Values I am writing. So these values are given 2.63563 second, then second value is 2.56 second, third value is 2.42 second, next value is 2.71 second, the next value is 2.8 second. Here our main concern is to get correct value. So for that, as I told you, first you should find out what is T bar. T bar means you will find out the average of these values. So you can write T1 plus T2 plus T3 plus T4 plus T5 divided by 5. Now, what will be next step? You have to find out delta T1, which will be T bar minus T1. Similarly, delta T2, T bar minus T2, then delta T3, which will be T bar minus T3, delta T4, which is T bar minus T4, then delta T5 is delta, so that this will be equal to T bar minus T5. Here some values will be positive and some values will be negative, but as I told you, for taking average we have to make the absolute, we have to take the absolute values of these values, so we can easily find delta T bar. For this purpose we will take delta T1 average, similarly delta T2 average plus delta T3 average plus delta T4 average plus delta T5 average whole divided by 5. Then we can write correct value. So as I told you, correct value of time will be T bar plus minus delta T bar. Correct? You have understood? Now suppose you want to find out its percentage error. So percentage error, we will take this delta T bar whole divided by T bar multiplied by 100, and you can evaluate, and this is your work, the valuation. Now we will study something else. Next thing is combination of errors. Suppose you have a quantity A whose correct measurement is A plus minus delta A. Similarly, another quantity is measured as B plus minus delta B. And you are going to add these two quantities, or you are going to subtract these quantities. Then what will you do? If you write A, suppose we write here A dash B dash, so that you may not get confused. So A dash plus B dash will be, these correct values will be added first. A plus B will be there, and then plus minus these two errors. These are errors. So delta A plus delta B will be added. One example I am giving you. Suppose you have a quantity, suppose R1 is 40 plus minus 2 ohm, and R2 is say 30 plus minus 1 ohm, and you have to find out the addition of the two. So what do you do? R1 plus R2, so 40 plus 30, 70. So 70 plus minus addition of these two errors, that is 3 ohm. Now suppose you have to find out difference, then what will happen? In case of difference, here R1 minus R2 you want to find out. So for that you will subtract these two, 40 minus 30, that is 10, plus minus, whether you will subtract this error also? No. Keep in mind, errors are never subtracted. If you commit one error once and the second error second time, does it mean that the two errors are going to compensate each other? No, your error will increase. So definitely this will become plus minus for you. So I think you have understood this concept also. Now suppose you are going to multiply or divide. In that case, what happens? So in that case, relative error delta Z, where suppose Z is AB, product of two numbers. Similarly, Z can also be written A upon B. So in case of multiplication or division, same process will be adopted. So delta Z upon Z equal to delta A upon A plus delta B upon B. Now let's understand it. Suppose you are given some quantity, suppose V is given, voltage is given as 100 plus minus 5 volt, and current is given as 10 plus minus 0.2 ampere. 10 plus minus 0.2 ampere. And we have to find out the relative error and percentage error in resistance. If you remember Ohm's law, V upon I. So first of all, we will take these values. So we can get here 10 ohm, but our concern is to get the relative error. This is value of Z, right? Because this is division. As I told you, Z equal to either A upon B or A into B. So here we have got Z. So in place of Z we can write R. So we write here delta R divided by R is equal to delta A upon A, error in first. So first quantity is, so 5 divided by 100 plus here 0.2 divided by 10. Now what we can do? We can take this R to RHS. R is 10 to get delta R. Delta R will be equal to this 5 upon 100 plus this is 2 upon 100 into R. Now delta R can be easily found. So this will be equal to 7 upon 100 multiplied by R, and R is 10. So we have got 0.7 ohm. So correct value will be 10 plus minus 0.7 ohm. We can also calculate percentage error. As I told you, we take this value divided by resistance 10 into 100. So this is percentage. By multiplying by 100, we can get percentage error easily. So that is simple. Take some more questions. Suppose you are given a quantity. A is it is length. So A is given as A equals 10 plus minus 0.2 meter, and B is given as 4 plus minus 0.1 meter. Now suppose we have to find out product, suppose Z. So we first take these numbers, we don't take these errors. So this will be 10 into 4, that is 40. So we have got Z. Now we have to get delta Z upon Z, where Z is this value. So we consider errors in each. 0.2 divided by 10 plus we consider this one 0.1 divided by 4. Now we can get delta Z, or if we want to get it in percentage, so what do we do? To get percentage value, delta Z upon Z, we multiply by 100. It means in RHS also we will multiply by 100, and that will be our required value. Now let's take errors in powers. So suppose you are given a quantity like, suppose Z equal to A cube B square C power 3 by 2 D power, suppose we are given Z equal to a quantity A power M into B power N into C power L into D power say Q, and we want to find out the relative error here. So if we write here delta Z upon Z, so it will be equal to, we put this power before, M times delta A upon A plus for this n times delta B upon B. Denominator will also be written like this, only with plus sign. There won't be negative sign. L times delta C upon C plus Q times delta D upon D. So this is how we can calculate the errors in powers. Now we are going to take some numericals whereby this thing will be obvious. So our question is, suppose x is given as a square bq divided by c root d, where percentage errors in ABCD are given. So delta A upon A into 100 means this is percentage error in A, and that is given as 4. Similarly, delta B upon B into 100 is given as 2%. Delta C upon C into 100 is given as 1%, and delta D upon D into 100 is given as 3%. You have to find out the percentage error in this quantity. So we can write total percentage error. So delta x upon x into 100 will represent percentage error. So we consider all the quantities like 2 delta A upon A into 100 plus 3 delta B upon B into 100 plus delta C upon C into 100 plus last one. Here power root means half power, but keep in mind, even if it is in denominator, that does not matter. While writing the errors, we take it positive power. So it will become 1 by 2 delta D upon D into 100. Now, these values are given 4 to 1, 3%. We can put the value to get the answer. I'm not doing that. Now, one more question based on it we are going to do. The next question is the time period of simple pendulum. As you know, T is given by 2 pi root of L upon G. In this question, some information are given. L is 20.0 centimeter. Here, the digit after decimal indicates the accuracy. So 0.1 centimeter is the accuracy. This can also be said that accuracy is 1 mm here. So you can say this is delta L. So 1 mm. And then time period for 100 oscillations is 90 seconds. Time period is given 90 seconds for 100 oscillations. Now here also we need accuracy. So the wristwatch used measures up to 1 second of accuracy. So we can say delta T is given as, capital T is given as 1 second. So we have to find out the accuracy in the measurement of small g. So first of all, we have to write this equation in terms of g. So for that we can write T square is 4 pi square into L upon G, or G equals 4 pi square L divided by T square. Now, what more? We have to find out the accuracy in the value of G. So we write it as delta G upon G. We can put it in terms of percentage also, but I'm not writing that. Here, 4 is dimensionless constant, pi square is dimensionless constant. So I'm leaving them. So we can write delta L upon L plus here power 2. So twice of delta t upon t. Now we have the values. Delta L is 1. So here this is 20. We can write these values. So 1 divided by 20. 1 mm accuracy, so not 1, this is 0.1 divided by 20. And then here 1 second is accuracy, twice of 1 second accuracy divided by total time is 90 seconds. Now suppose we want to write this value in terms of percentage. So as I told you, to convert this into percentage, we write delta G upon G into 100 equal to these values. We multiply by 100. So 0.1 divided by 20 plus 2 divided by 90 multiplied by 100. Now, what do? We just evaluate it and it will come out to be 3%. I think you have understood. Today, it is end of chapter 1. Thank you, Team Educate.